Just a couple of things as reminders. You should, no matter if it's an absolute value or a radical like the ones below, you should be able to tell me the vertex right away on either of them. What's my vertex in this first one? Okay, 4, 3. If I have something in the absolute value, if I have something underneath the radical, okay, that's going to be my x value, but it's the opposite of what I would think it is. And then any value that's out here will be my y. That's always going to give me a starting point to work with. Now, when you're doing absolute value, remember, it's going to be that V shape. Okay? It might open up, it might open down. Now that I think about it, how would I know if it's going to open up or down? Because I should know before I ever do anything. If there's a negative out front, it's opening down. It's going to look like this. If it doesn't have a negative in front, it's going to open upward, okay, like a V shape. And it's symmetrical, like a parabola is. So what we'd done before is once I knew that vertex, that was sort of my middle value, we were looking at a couple of values that are less and a couple of values that are more for my x's, because I know that these two are going to be the same, and I know these two are going to be the same. So I really, as long as I'm careful, only have to plug two numbers in to get the whole thing. So let's say I decide I'm going to use the 6. Okay, 6 minus 4 is 2. The absolute value is still going to be 2. Plus 3 is 5. That should tell me that both of these are going to be at 5. And it gives me a pretty good idea of what that middle number is going to be. Again, I can choose either one of these. It's symmetrical. 5 minus 4 is 1. Absolute value of 1 is still 1. Plus 3 is 4. I'm good. These, typically putting them into a table is going to be the easiest way to go, just to kind of keep yourself organized with things. However, when we move down, okay, when we move from absolute value equations that look like these into what we're looking at in 3 and 4, now we're looking at radical functions. And then it also, notice, asks you to identify the domain and the range. Now when I get here, I can still find my starting value the same way I did above. Okay, where's this particular graph going to start at? Okay, -6, -3. Okay, this is the one where we're going to start. It's not going to be a vertex because when I'm doing a square root equation, those typically are going to look like this. Yep, no matter if it's under a radical or it's an absolute value. If you just change the sign on the one that's in there, yep, that'll work every time. So that gets me my first point. Now again, I see, oh yeah, it's going to be kind of one of these curved things. So, when all else fails, this is one of those, if you really wanted to. You could say, okay, so let me clear this out. Second and x squared will get me the square root sign. So I could on this, I don't mind if you use the technology to try and help yourself out some with these. That's not a big deal. I'll go to graph it, and I notice, hey, there's the point that I made already, and it looks like it just kind of keeps going up and to the right. So if I want some specific values, I could either plug some numbers in, so maybe I'd plug in -5, -4, and some of those, or it's okay to bring the chart up and let it help you on this. So there's my -6, -3 that I knew I was going to have. If you go less than -6, yes, you would. Because what happens is, remember, with a square root, if it's negative, it's going to be imaginary. Well, that doesn't show up on my calculator. So any value that's less than -6 would cause this to be negative. And negatives aren't going to work. So I got to stay in this area. And again, you don't have to plot every point, even if you just plotted the ones that basically come out as whole numbers. Sure. If you got, let me leave that up for just a second. Okay. When you're typing these in, okay, notice on mine how I close my parenthesis after the +6. If you forget, I'm going to do a little side comparison here. If you forget, what the calculator is going to do is, it's going to do all of this stuff and then take the square root. So if I wanted to do the square root of x plus 6 and then do the -3 outside, I got to make sure I close that parenthesis first. So that's how you could end up with a different graph on this one. This is the way that we want it to look. And again, that's fine to have on there. So as long as you have that, okay, that's fine. That's enough work to be able to show me that you know where things are coming from. Now, if you think you're going to forget it then, actually write yourself a note like, on calc, this can't be less than -6 because I can't have a negative. Write yourself some of those notes as you're going along. So when you do look at this later before the final, it's like, ooh, this is what I have to do. Okay? Yes, ma'am. All right. Hang on, I'm going to put the graph back up here for a second. Hang tight for just a minute. Couple of things that can happen to you on these. Again, make sure when you put in square root, it already gives you a parenthesis. So if you put in a second one, that can kind of move you a little. The other thing, again, is here's your typical window. Sometimes if I put one up or you're looking at it, it doesn't quite look right, see if your window is where it normally would be. Because that might take care of it for you too. Okay? So, then, take a quick look over the back here and see what's happening. So now we're starting to see some parabolas. We're seeing some squared curves. Again, I have no issue with you coming to the calculator. You can just plug in numbers, but again, if you just type in your expression, make sure it matches, and graph it. Bless you. Now, two things to remember. First one is going to be, and I'll get my points here. It always helps to get points. So any of them that are going to fit, I'll go ahead and get those in here. Now, before you start connecting those points, one thing to remember with these, when you're graphing these with the inequalities, I have to figure out if my parabola is going to be dotted or solid. How do I figure that out? Right. If it's or equal to, I've got myself a solid parabola to work with. If it's not, then I have to do dotted. That's how I show the difference between those. Okay, so that's part one. With the inequality, it means we're going to do some shading. So if I'm going to do some shading, you've got to use a test point, unless you're real good at this. Do you remember what our favorite test point is? 0, 0. Okay, so I notice 0, 0 is inside my parabola. So I'm going to test 0, 0, and if 0, 0 works, I'm going to color inside. And if it doesn't, I'm not. So any place I see an X or a Y, I'm going to replace it with 0. If there's an or equal to line, it's solid. If there isn't one, it's going to be dotted. Is 0 greater than or equal to -1? Yes. Since that's true, I shade where the test point is, which is inside my parabola. If I'd have gotten a false, I'd do it outside, because it'd be the opposite of the place that I'm looking for it. Okay? That's how those work. And then going along with it, because we always want to have all these tools available, for 7 and 8, inequalities, but no graphs. So, I need to factor this. What multiplies to positive 8 but adds up to negative 9? And yes, it is doable. Negative 8 and negative 1. So if I solve this, if I set each of those equal to 0, I get my 2 zeros. And I'm going to make a quick sketch here. When you do these, for your interval notation, it's either going to be between these 2 points, or it's going to go out from each of them. I can make my test point anything. Let's say you decide you want to stick with 0. So I'm testing to see if these work. Just like before, plug in zeros wherever you've got a variable. 0, 0, let's see here. 8 greater than 0. Yes. So since 0 is here on the outer edges, that means my solutions are out here on the outer edges. And since it's just greater than, I'm going to use a parenthesis. Now don't stop. Interval notation. So I take each piece from negative infinity to, 1 hardy. And then it starts up again at 8 and heads off to the right. That's the answer I'm trying to get to. Right? And then I'll admit it, the factoring ones, I made them a little bit nasty, just to make you get after it a little bit more. They won't be that nasty on the final. But I just wanted to make you think a little bit. I will be after on Tuesday and Thursday like normal. No. Yes, I'll be before. Actually, every day I'll be here before. Yes, sir. What's that? If this were equal to, I would use brackets. But since it's not, I just use these. 44 questions of multiple choice, and I believe on the final there will be 21 short answer. I think that's the breakdown. I'll double check and make sure.